that it does not feel necessary. The problem is solved. Because it's moving parts, there is what we call loss. Okay? For instance, what would you think if I gave you 10 states, right? 10 states. And then at the end of the day, you play around, I find you with something. It means you lost a lot, right? That's what happens with the motors. They also lose some parts of the data. Sometimes the model brings the data is not necessary. When you go to necessary, the model tells you it's not necessary. That's why we do something called fine-tuning. Fine-tuning is we go back and tell the model train with that particular data. So when we are compiling, we try to get the loss and the metrics. So the metrics can include most commonly is the accuracy. You want to see the degree of accuracy of how your model has learned. Has it learned to 70%? Has it learned to 90%? Has it learned to 90%? If it has learned, so if you have two models, one has learned up to 70%, one has learned up to 90%. Yes? 95 and 70. 95. That's true, but I can assure you that your business is fair. Even when it's 20%, you go with it. You make no scenarios. But usually we take the highest accuracy. It means the model has learned with a high degree of confidence. You know the confidence interval. What is the confidence interval? You guys don't need to do calculus, those things. What is the confidence interval? Wow, interesting. It's always 95. Anything below 95 is not true. And anything above 95 is factual. Right? So if you have your model at 90, we can say, okay, let's go with it, but with a pinch of salt. When something is above 95, we can all agree that it is good. So we do the compilation, metrics, you get the accuracy, the F1 score, the R1 score. You can note down this thing. And then now we do the prediction and we do the evaluation. So the evaluation is what returns what we put into the compilation. So when we are evaluating, we are returning the loss and we are returning the accuracy, the metrics. So metrics, you can choose whether you want the accuracy, the precision score, the recall, the F1. There are many forms of metrics that we can use. Right, so I've been talking about neural networks. That's a neural network. That's essentially a neural network. That's how it's built. That's how it works. Fx equals to x times w plus p. For people who do mathematics, who are then doing mathematics and you're so keen, which equation does this one look similar to? Yes. Right. Oh, and I've remembered. So I've seen you guys, some of you on the phone, some of them on the television. So I'm going to put it on the same thing. I came with branded pens. I'll be giving them out to people who are answering things. Yes. So the gentleman gets this pen. These are Google Developer Group's pens. They open the same this to me. Right. So this is y equals to mx plus c. That is deep learning. That's just deep learning. Yes. You have a problem fx. That's the function. You have a problem, fx. But you know x because that is your data. That is your input. When you multiply it, with W and you get V. So W here stands for weights. We call them weights. Right? I'll talk about weights. One is very important. Plus B, this stands for bias. Like I told you, when you're training your model, there will be some data that your model ignores, but that your model puts aside and trains the rest. It means the model is biased. It's creating some sort of bias. So we have to calculate that the factors of bias, right? If the data equals to 100, you've been able to learn from this data, and you're giving me 97. Where is the grade? The grade is what you did done. What you did is done. Something of bias. Then the 97 comes from the weights multiplied by the input. So weights. So when we have something, I need this function. I need to explain this later. So you've seen we have the function, the weights, the input, and the bias. But I need to explain this next. I'll talk about the human brain making and all that. So this before that, there is something here where I'm saying that neural networks can have a state or be a state. This simply means that for a neural network to have a state, it has weights. And for it to have weights, it has knowledge. So weight is knowledge. Okay. Let me give you this scenario. When you take an image, during that, the whole image can just be objects, right? There will be those corners that where there is no object. What does it imply? That those dark corners, so like an abstraction, so the rest of this is done. What does it mean? There is no knowledge. If you're looking for me, you will not find net the edges of the corner. You get what I mean? I'm taking a photo. Let's say a passport photo. And I want to look for your ears. Where do I look? Do I look at the edge of the photo? I look closer to the outline of the person in that photo. So, and remember, photos are broken down, or it's just a combination of what we call pixels. So one pixel which contains information comes together, compacted together, with you and image. That's why when you take a photo with the itel phone, the photo is a bit blurry, not consider a good quality compared to iPhones and Samsung. Instead, they have high resolution. But in this case, it means they have more compacted pixels to give an image a clear view, right? So each pixel has some information. Either it doesn't have information with that size, or it has information which is your outline, your eyes, your hair, your blood, right? So when we are training a model on that image, when it makes a pixel that has nothing, that is zero. There's no knowledge in that pixel. So at that point, the neural network is stable. But when it makes a pixel that has something to do with the human, or something, then it records that knowledge in that pixel, and that becomes the weight. And we call the pixel as the neural network as having a state. So the combination of all those weights together form up you as a human. That's how the model learns. It brings together all those weights with that information and then analyzes them, puts them together this form looks like so to output. This form looks to be of the dot, so to output the dot. Right? Yes. I've talked about this input hidden neurons just for. All right, so this is how it really kind of works. You have input x1, input x2, input x3. This could be your age, could be your gender, could be your tribe, right? And let's say we want to build a model where we are able to categorize or identify people based on their gender, based on their age, based on their any feature, you know. So we pass those features. As those features go through a hidden layer, they are awarded weights. So for each input feature, it gets its own weight. It's essentially saying, go into this data and identify the address. So if address was x1, it means it will get weight 1. All right? If the other input feature was your age, and that is x2, it means the corresponding weight, which is carrying that knowledge, is w2. So the training lands happens within the hidden layers, and then we get y1, which is the output. So the output is, are you a boy, are you a girl, are you white, are you black, are you sick, are you feeling fine, you know, that is the output. And so, just a little bit back, there's something here where we have activation. Okay, I'll talk about activation later, this method. So I have this neural network that I want to build, right? It is supposed to predict the price of rentals in Kabale, right? As an individual, when you want to settle down and be in a room, before you get into that room, there are things you consider, right? What do you consider?
Rent.
Yeah?
Cost.
Yeah?
That rent.
The rent? Yes? No. Yes, that is okay, but no. I will explain why. Okay? What do you consider? Allocation? Yes. What else do you consider? The space? Yeah.
Self-contained.
Self-contained or not? Yes. The environment is favorable. That's also goes to the location. So 1, 2, 3, 4. Those are 4 pens, and they're getting done. So the rest of you just keep answering that with no pens. Okay. So what you ideally consider when you're going to choose the location where you're going to rent is, for instance, you consider, is it 1-bedroom place? Is it a single bedroom? Is it double bedroom? Okay, those are things you consider. Before you come down to the price, does it have electricity or water? What is it? If you want to rent a place in Harvard, you want to consider this is friendly, the university. Okay? You don't want to just stay at White House in coming to study, unless you can. I know those guys. And I think some guys here will have things at White House. But those are things you consider. You may also consider the age of the building. You want to go into a building that was built by a those are like 50 plus years back. You want to consider a new building. You want to consider the area. So how big the area is, that it has the gate, the overlook. So those are things you consider. And once you consider those things, you now look at the price the landlord is telling you, and you weigh. Right? That's what we do in our heads. Because if the place is very far away from the university, then I have to incur 2,000 every day for a border. And then you're telling me to pay 1 million. Do I go for that place? I would rather go for a place where I'm paying 200, but I can walk to that university. So all of those scenarios can be programmed, can be built into an AI model, right? So when you're building, for instance, a neural network, and you want to, for instance, predict the price of a building or a rental somewhere, you consider like the area, like I said, the bedrooms, the distance, the age. Okay, so you provide that data. That data goes into the hidden layers. They are awarded weights. If there is no information, zero. There's some information, there is some weight. Until you get the, the price. So the model is able to tell you that, but you've seen, how many of you have used safe border in Kampala? How many of you have used safe border? You use safe border. So you guys just be walking around Kampala like, eh? You be walking around Kampala like you're homeless or something. No. It's funny, but it's also very important that you use these products. Safe Border is developed by Ugandans, run by Ugandans. You're going to build those products yourself. That's the end goal. That's why you're doing computer science, IT, or even if you're coming from another field, you need to test how other products work. For instance, if you want to move money around, you can use cheaper cash. How many of you have heard about cheaper cash? It's developed by Uganda. One of the founders is Uganda. Though it's based in the USA, but one of the founders is Uganda. There is another application called Eversend. It's also developed by a Ugandan who is an alumni at MUST. In computer science, went first, developed his application, and it's being used. So you learn how these things are working in real time. You may be using safe border and you realize the gaps within it. You're like, no, why don't they add this feature? Why don't you add it there? Why don't you build something that fits safe border, right? That's how ideas come back. You use other people's platforms to learn. So next. So I talked about activation functions. Can you add the second? Right. So activation functions basically are what we call normalization. The work of an activation functions is to normalize. What's the time again? Okay. I want us at around 16:10 to get into the practical bit of it. I know guys are already tired of me speaking. They had the power of just pressing me out and never speaking again. But so activation functions do what we call normalization. And this is how it happens, right? You have a feature, it goes into the hidden layer. There is some loss happening, there is some gains that are happening, and then you get to the next. The question is, how do those two get balanced? Okay? There is a weight here. So there's a part which has knowledge. There is a part which doesn't have knowledge. But at the end of analyzing this two, we want to still say this is a person. How do we get to that? We normalize the what is happening in the during the. So when a neuron doesn't have information, it has right. So the input times its weight, which is 0, becomes 0. When you get a neuron that has knowledge, so the knowledge could be something like 10. This thing is just a word for put random numbers to the knowledge. Okay? But it's just not random. It just depends on the intensity of the knowledge. Okay? So you have your input times this way. It could be 10, could be 20, could be 30, could be negative. Can you go back a little bit? All right. So in that equation, I want to calculate price. You have x1 w1 having a 0, right? You have x1, which was a feature. So let's give it 1. But that's also 0. We have x2, which we can give 2, right? But its weight is negative 20, right? So we have now 0 plus negative 20. We can go to W3, and let's say the weight is positive 5 times 3. That is 15, right? So 0 plus negative 20 plus 15. Then for W4 and X4, you can have also a negative 4. What rate of the weight do? We're doing something like negative 21. 0 plus negative 21. So that's what we do. Negative 21 plus 15. That is still negative 6. Plus negative 4. That's negative 10. That's what we get. And that negative 10 is translated, when we are dealing with metrics, it's translated in percentages. Right? Now, when I talk about predicting, what comes to your mind in terms of mathematics? When I say I'm predicting something, what comes into your mind that is close to mathematics? Probability. Probability can only be between 0 and 1. 0 and 100, right? So when you get something that is in two negatives, essentially means it doesn't exist. Your model will say this is a cat. How? How was it a cat? From combining all these weights together, we got a negative. How did you come up with saying this is eventually a cat? And it even gives you an accuracy of 90% that this is a cat. How does it happen? We normalize conversion. So we normalize that using these activation functions. For instance, sigmoid, which is the most popular, it's one of the most popular activation functions. It maps only the real numbers to a value between 0 and 1. That means if you're going to get a negative, it's ignored. Only the values that are real will be mapped to either you're getting 0 or 1. That is between the percentages, right? 0 to 100. Okay. This is what there's a curve. There is an equation. You can even research about these equations. That's why I said the mathematics gets tougher when you get into deep learning. So these real numbers, these values that have been given to you between 0 and 1 are plotted across a gradient. Okay? And as they are plotted, the gradient diminishes or vanishes on both sides. There is one that eventually goes into negatives, there's another that goes into high positives. So we get a problem called vanishing gradients. And so in terms of effectively giving us a very good prediction, sigmoid always falls short of giving us an effective prediction. But then we get to solve that problem using ReLU. So ReLU is rectified linear unit. This one simply identifies a function for all the positive values of x and then ignores anything that is negative. Anything that is negative. So it starts from 0 to whichever value it will give you, as long as it is positive. While this one addresses the vanishing gradient problem, it also has some challenges. We can go to other functions. So we come with softmax. Softmax usually deals with multi-class classification. So multi-class, I'm talking about more than 2 classes. So if you're trying to predict between, for instance, we saw the other neural network that we had was we only trying to predict the price. So if you're trying to predict the price, you can use it already. That one is okay. But if you want to predict the price, you want to also predict the cost of probably electricity. So you've seen that the room has two bedrooms. It has a separate kitchen. It means you have two rooms, or three rooms, two lights. The electricity bill is higher than a single room. Okay. So you can also add that as something you want to predict. So you now have two things to predict. You could also add, you want to predict the cost of water that you will spend when you're in that place, right? So the moment you're trying to predict beyond price, the price of rent, the price of electricity, the price of water, you're now getting into multi-class classification, right? So with multi-class, we use things like softmax, okay? Because now this one takes all the possible probabilities. This is what is going to happen. The probability can only be between 0 and 1. But because you have three classes, while one gives you like 0.7, the other will give you like 0.2, and the other will give you 0.1. When you total them all together, it will give you at least 1 or 0. Okay? Because you're dealing with 0 to 1 sort of prediction. Then you have turn edge, just gives you a range between -1 and 1. So the thing is this, the idea about this thing is that I'm just talking about them, not for you to completely understand them, but be aware about this thing so that you learn more about it. If you are in this session and you think that the knowledge I'm going to give you is enough to make a machine learning engineer, sorry, I'm also still learning because the industry changes. So when I talk about this thing, just note them down, go and read more about it. I cannot exhaust the mathematics behind these things. I talked about loss functions, right? Regression. Did you guys learn about regression when you're doing machine learning? You didn't want to talk about regression. You didn't do regression. Okay, so these things apply to what we call supervised machine learning, right? So under supervised machine learning, you have regression. That means you're dealing with numbers that are continuous. So for instance, when you go to a set product, you say, I'm at Maclaren house, I want to go to my house. You tell me the price that is going to take you, right? That price is calculated using linear regression or logistic regression. Okay? The prices can change depending on that distance. For each distance, there is a price. For each distance, there is a time that it will take you to arrive. When you're dealing with that kind of data, you want to predict that if I'm stuck in traffic here, how long is it going to take me to reach home? You're dealing with continuous data. And so we do that using regression. Okay? But so I'm not going to go so much into that, but when we are dealing with regression, we first losses also. Okay? Because we are training our data, our models on those data. We first loss, and how we solve it is we use the mean squared error. Usually this is to get an average square difference between what was the predicted value and what is the actual value. For instance, if your landlord charges you 200,000, or if you come and ask the tenants around and say, hey, this place, how much do you pay for it? And it is 200,000, right? You gather the data that you need, you can give it a machine learning model to try and predict the price. Then the machine learning model tells you, based on this data, you should be paying 400,000. There's a lot of loss that has happened. Why with the same data does the landlord charge 200,000, but with the same data, the model is telling you to pay 400,000. So the actual value is 200,000. The predicted value is 400,000. So you get the average squared difference to mitigate that loss. Okay. So you find that in between the 200 to the 400, what you can agree, okay, I think I can give you 200. Okay. Between the actual and the predicted, no, I think 250. So you're trying to get something in between. Then the mean absolute error differences between, so this is the average of the absolute differences. Then classification. So classification, we are dealing with discrete data. You know that discrete data doesn't change. An image is an image. It doesn't change. Okay? A human is a human. It doesn't change. Your age is what changes, but you're still a human. So classes, these are categories. Categories should not change. Once we categorize you as black, even if you bleach yourself, you still remain black. You won't change. Okay? So under classification, we are dealing with classes. But also under classification, we face the same losses. And for us to mitigate them, we do the binary cost entropy loss. This one's just getting the measures that it measures the difference between the predicted probability of all the positive classes and the actual binary level. The fact that it is binary cost entropy loss, it means we are dealing with that prediction where we are dealing with either a yes or a no. So binary is two things: yes or no, 0 or 1. But when you also go into multi-class classification, right? Just like you are predicting prices of rent, of electricity, of water, is all already multi-class. So even with classification, when you're dealing with multiple classes, more than the yes or no, the moment you introduce a maybe, those are 3 classes. So it's more than 1. Then we solve that using categorical cross entropy loss. There are other sorts of loss functions between regression and classification. Okay. So this is how you mitigate the losses in your data. Next. I think we should be winding up. Optimizers, I'm not going to talk so much about optimizers. Optimizers is, trying to iterate, the updates that the model parameters are giving you based on the gradient of the loss with respect to each parameter. If the bedrooms were 2, right, and you're telling me to pay 1 million, what was the loss to that? And how do I optimize the 2 such that between 2 bedrooms, this is the accepted room? How is 1 bedroom becoming more expensive than the 2 bedrooms? So with the parameter that you have and the gradient of the loss that you achieve in this prediction, that's how the optimization comes in. So we use that sort of optimizer. We use RMS prop, and there's also Adam down there. If you move, there is Adam, which is the most commonly used. Okay. Again, so this is a simple neural network. Can move. There is already provided. Next. This is also simple neural network. Let's move. Okay, so I'm going to talk about these next 2 slides, and then we'll try to go into the points. So, I've talked about loss, right? We have what we call the forward pass, or what we call forward propagation. Where is this propagation in mathematics? You did? You did propagation. Okay. It's like I did my own math. I was doing my own form of math. But the things are there, propagation. So, everyone's telling me that you need to do propagation. Okay, alright. How many of you did math? You did math. Good. So you don't want to tell me that you did an inverse of a function. I think I'm saying inverse of propagation. You know? So here's what happens. X1, we are saying, so this whole, I'm going to demonstrate this based on, we want to calculate the average temperature. Okay? We want to calculate the average temperature. To predict it, not calculate, I want to predict the average temperature based on the previous temperatures. You guys are lucky. I reached here and I was almost buying land and setting up the home. Mother was dying, sleep outside. The temperature there is fantastic. It's called some of them so anyway, so let's say X1 means temperature on Sunday. Average temperature on Sunday was 73.8. The temperature on Monday was 75.8. The temperature on Tuesday was 78.2. That's what we have as data. Then we give this data to the model, learn from this data, and tell us today's temperature or tomorrow's temperature. What does the model give? Negative 10.4. How can that happen? So the other things of losses and all that's coming to play. Okay? How do you mitigate that? Philip, when you have a negative number, how did you turn it into positive? There's some time when you used to do the inverse part. You did that? Yeah, that is by negative, that is easy. Easy peasy. You have a negative, divide by negative, it goes. By the time we use to, I'll call it propagation because that's what I was talking. But there's a time we get an inverse of that very number to turn it into positive. There are some different mathematical formulas you can use to get a negative number and turn it into a positive. The easiest is by cancelling out the negatives. So this is essentially what we do. Okay? I'll explain this when we are looking at it. Let's try to go. Right now you guys are already confused. The same thing can also happen the ground truth. So if I looked at the weather like for today, it will tell me the temperature is 80.8. But remember, the model said it is negative 10.4. So what do? We calculate the loss error. So the loss error is we get what is the ground truth minus what it has given us. Okay. By the moment we say minus what it has given us, we are cancelling out the negative. And then we power the difference of that by 2. Mathematics. That I can assure you. You go to YouTube and find videos of Indians and all that. They will tell you they were starting deep learning. And the first thing you do is Tessa plus TF. My friend. You will follow through, right? You follow through. You look at statistics. You look at predictions. They are not make sense to you until you apply mathematics to them. So math is very, very important. Okay? You will get negative 10 and you can't tell your boss like, no, the model didn't predict anything. It gave me negative 10. You should have tried to propagate that negative and go with your boss with positive. Okay? Next, let's go through these things. Let's go through, and also I already have this. I have a site where I put my slides, right? So they are publicly accessible. When I'm done, I'll give a link to Philip and Simon. They'll share with you, right? So you can read more about these things. Next. Okay. So this is the model layer, the perceptrons, the LO2 loss, the gradient descent. All this is math. Let's go. Okay. Now, of all the things that I've said, I want to show you again the ML or machine learning workflow. First, we import the libraries that we are going to use. All right? Keras, because we are going to use Keras, TensorFlow, we are going to use TensorFlow, Pandas, we are going to use Pandas. This is like the skeleton of how you develop and train a machine learning model. There are other things that are between, but I'm trying to show you the insertion workflow. After the, so first of all, I'm importing sequential. It means I'm going to use the sequential API. I'm importing dense because I'm going to have a dense layer, the hidden layers. We use dense for dropout. Then I'm importing an optimizer because I'm going to have losses and all that. I need to optimize. And so I'm importing Adam. Then after the import statements and before I create what we call the instance of the sequential function, we do data processing. So you clean your data. If your data has missing values, you either delete the rows and columns with missing values, or you randomize the values and put in random values. If your images are, like for instance, neural networks do not understand images. They do not deal with images. But your data is an image. So what do? You pre-process that image. You convert it into pixels, and the pixels into vectors. Your machine learning models do not understand videos because videos are not real. Did you know that? Videos are not real. Just like colors are not real. You go find out why videos are not real. So they do not understand videos. But what you do is you get a video, you break it down into frames. So frames are like images. You break it down into frames. You get the frames, you break them down into pixels, into vectors. That's what we do with data in preparing the data. If there are images, if I got 3 people here and said, let's go and take images of this school or university campus, buildings, all of the 3 people, even if you have the same cameras, you people are going to have your own function. Someone will take landscape, another takes portrait, another takes filters, another takes. So I need to process that data to resize it so that all images have the same size. All images are turned into the gray scale. So we gray out the images and turn them into black and white. So all that happens before you even think about which model, how many layers you want to build. Okay, that's why I say that data, understanding data, very important. If you're dealing with numerical data or what we call clinical data, the student is missing some marks. You train your model with that data where there is some empty values. It means your overall accuracy is effective because it didn't learn with the missing value. So what you do, you either cut out that student. Imagine you wanted to train a model to always predict the best performing student from Kabale before graduation, right? You want to use their existing marks to always predict before even graduation happens. Then I'm training the model and giving each student with missing marks. Will that give me a clear picture of who's the best student? No. It means I can only train it with students that do not have retakes, that do not have missing values. So when you have that sort of data, you don't aid that people will detect missing values. They give you that data, you pre-process it first, eliminate the missing values, put out the retakes and all that. Then you go into creating the instance, which is sequential. Then what you see there, model.add. So the model.add is I'm now adding my layers. Okay, so these are two layers. I have one layer and I'm giving it an activation function of ReLU. It's the input layer. So the very first layer of the neural network will always be the input layer. This is where you say my data is here. So the input is 100, the dimensions. This I was dealing with images, or I was dealing with numerical data. That's where I put my data. Then the last one is the output layer. I'm giving it an activation for software. And also to note is that when you're building your neural networks, each layer can have a different activation functions for reasons. If this one has a vanishing gradient, the rail will come and solve that problem. When the rail is faced with a problem, the next layer, which is using like time H, will also solve the problem the previous layer. Then you're calling the optimizer. You give it, so the optimizer also takes what we call the landing rate. The landing rate is the milliseconds of how fast the model should land. You could reduce that to 0.001, or you could have it 0.0001, which means it will land slower. It will take a long time to land. Then I compile by providing the optimizer, the loss function, the metrics that I need. Then I split my data and load it. Okay, so the data is always split between the training data and the testing data. The training data is the data that the model will learn from. In the testing, just like the name test, we use it to test the accuracy of the model. Then you have the fitting cycle. I say fitting is one. Why do we use fitting? Then the fit. At that point when I said model will fit, what am I trying to do? Okay, yes. Yeah, kind of fitting, but the actual term is we are training. We are training now the model. So in training, we provide, so X-train could be the features, and Y-train could be the labels of, so no, both are features. X-train are features of the training data, and Y-train are the features of the testing data. Or sometimes you may mix both depending on what you want to achieve. You could have X-train and Y-test, or you could have X-train and Y-train. Epoches are the number of iterations. So it means my model will will repeat the same process of training 10 times. Okay? Batch size is, you have 100 images. And of course, you know that you cannot train all the images at once. So you divide the images into batches. Be like, no, first train with 32 images. So keep training with 32 images out of the 100. And when you do that, so the validation split is how you split your data. So you tell the model that please, for instance, this is 0.2. Yes. So the 0.2 tells the model during training that 80% of these images, so that means 80 images are for training. The other 20 images are for testing. It's for the split. You split your data between training and testing, and you give it a percentage. The most common percentages we have is 70 and 30, 80 and 20, 90 and 10. Okay. Then we have the predict and we have the evaluate. Next. Those are so let's press through. Ah, so for instance, it is very hard for humans to know. If I showed you these things, like what is there, it is very hard for you as humans to know what is two out of those different handwritings. If I told everyone here to write two, you write it different. And then if I ask one person to go on identifying what you guys have written, someone will say that, no, this is not true. This guy didn't write true. Because we write differently. But machine learning can overcome that problem. Right? So I'll share a link where I've written an article on how you can do a digital handwrite and handwriting recognizer. Let's go. Okay, now for this, I need to stand here and show you some of these things now. I'm just going to stand. All right, so okay. Let me try to. Okay. Reverse at that. One second. So this is Google Colab. Like I said, we can only write our machine learning code in special IDEs, right? Locally, you can use Jupyter Notebook and PyCharm, and download PyCharm, but we prefer notebooks. So Jupyter Notebook locally on your machine alongside PyCharm. For online based, we use Google. So this is online based. It's not on my machine. And because it is online based, I use Google's cloud resources, not my computer resources. And this is very important. We do not have strong machines. Like I said, there's only one computer in this whole room that has a GPU. You can imagine. It means we all have CPUs. Is there someone here who has more than 80 GB RAM in their computer? No one. The rest of us have 4 or 2 GB. Now I can assure you for a fact that if you're going to go into deep learning and you try to run, like for instance, this is a complex model. I'll tell you that. You want to run such a complex model on your 2 GB RAM, be prepared, like on the side, you go and buy fresh beans, put them in a saucepan with water, then put on top of your computer. Because by the time the model is done, the beans will be ready. You know? In other words, your machine will crash. Because 2 GB is not enough to train this model. Likewise, 4 GB. You can try with 8 GB. You try, you leave the model training, you go and watch United beating Liverpool, you come back, you bite commando, you eat, you sleep, you wake up, it's still training. But when we are doing this, I want to reconnect this and then I'll show you the resources that I'm getting for free. So the guys at the back may not be able to see everything here, and well, I have nothing to do about that. But be, have faith. The Bible says the last will be the first, and the first will be the last. So we just hope that I'll share this thing, this whole notebook to you, and since I've written the report, you can copy it and do your own things. I just hope you don't do this as your final year project. Okay, so I'm going to pass through quickly with these things. So in this code lab, I'm using Keras NLP. Keras NLP is a sub package or sub library of Keras. And this is particularly for natural language processing. So if you want to do natural language processing, you don't have to use Keras as Keras. There is a particular or specific sub library for it. If you want to do computer vision, there is Keras CV. Okay? So instead of fighting with Keras and trying to bring it down to computer vision or to NLP, use the specific sub libraries. So in this library, I use Keras NLP, and I have a pre-trained large language model GPT-2. So right now we have GPT-4. For people who have used ChatGPT, we have GPT-4. But the very first earlier models was GPT-2. We have that from Google. Okay. Then I'm also going to use TensorFlow Lite. Like I said, I'm using Keras, right? It runs in GPUs and TPUs. But at the end of this model, I want to release the model and put it in an Android application. Okay? The Android application runs on a CPU. What do? I convert the Keras model to TensorFlow Lite. These are challenges that you will meet, and you need to know when you're supposed to do X or Z. Okay? Okay, nothing here to see. So, this is very important that for me, before I run this whole notebook, I need to change my runtime type to choose a GPU because I'm dealing with Keras. So when you look at here, for instance, the runtimes that Google Colab gives you. First of all, by default, it runs Python 3. Okay. Then you have the hardware accelerators. So you have a CPU, you have a GPU. These are advanced GPUs. If you want to get these advanced GPUs, you have to pay. Then there is a TPU. So TPU, that is a tensor processing unit. So you most likely, when you're going to deal with Keras, you're most likely going to choose a GPU or a TPU. If you choose a CPU, I can assure you that no matter how correct your code is, you're going to get errors. Okay. But if you're doing TensorFlow, then a CPU is okay. You can just deal with the CPU directly. So I have a TensorFlow. I'm in a GPU, so I can connect my runtime. When I click on connect, it means I'm connecting to Google resources. I'm not connecting to my machine. So I'm going to use Google's RAM, Google's space, okay? Because it is based in the cloud. You know how you have that 15 GB in your Google Drive? The 15 GB is on Google servers, not on your phone. So it's the same thing that happens here. And if I'm to check what it gives me, so it is giving me 12 GB RAM. It's giving me a disk space of 78 GB for my data, right? So all this, I don't have to utilize my computer's resources. It means, unfortunately, I'll never roast some memories on it. So this here, I'm trying to get Keras NLP. and the TensorFlow text version. So some of these, so I'm going to run through this because we don't have much time. It's already coming to 5, and I intend to finish by 5. So, but I've written this whole notebook with explanations of everything that you can sit down, run it, read what it means, and understand. So here I import all the necessary libraries, NumPy, because somewhere may deal with numbers, Keras NLP, TensorFlow datasets from the TensorFlow hub, TensorFlow text because I'm dealing with some text in it. I import Keras from TensorFlow itself, then the interpreter. So I'm trying to interpret text, converting it into machine code so that I can do auto-completion. Then I import time, trying to calculate the time for when this is done. So I've given you an example, an introduction into what large language models are. You guys are using ChatGPT, or those who have used Gemini, you just go there to ask questions. You don't know how these things have been built. You don't know why ChatGPT is ChatGPT. So it's a large language model, and I've tried to give you some bit of introduction about it. Google right now has a couple of large language models. We have BAT, we have Lambda, we have PAM. PAM now is version 2. We have Gemini. Okay, so Gemini is the current large language model we have. Then there's also an introduction in particularly Keras, natural language processing. Okay. Then, so right here I get to load. So when you're trying to do NLP, you may not have access to GPT-4 because you may have to pay for it through OpenAI. You may not have access to Gemini, the current large language model from Google, because it's not yet fully open source. We have another version that is open sourced, but these are the ones that are open, so they are free for you to use. So the most common ones that we use is GPT-2 and Google, but these ones are openly for free. And by pre-trained models, what we're trying to mean here is one. You see how you go to ChatGPT, ask it a question and it responds, right? It means it has been trained on data for it to give you that information. Now imagine someone giving you access to that GPT-4. It means it's already trained with this data. Okay? What we have as it's a claim, because GPT is closed, we don't know what happens there. But they claim to have trained their model on 1.7 trillion parameters. 1.7 trillion parameters, which took them about 2 months to train. 2 months to train. On about the size of this room times 4. So this room stacked with servers 4 times. That's the amount of computing power they have to use to train a model on that data. 1.7 trillion parameters. On Monday, we got access to Grok. For those who have been on Twitter or use Twitter, there is that thing Grok. It's Twitter's large language model. So Elon Musk open sourced it. The whole of it, every code, you can now also own your Grok. You just don't have to go and get the code. The challenge is it is trained on 314 billion parameters. So again, there's no machine here that can train it unless we combine all these machines together. Maybe we can live somewhere. But these ones are optimized. They are trained on very less parameters. I think GPT-2 is like 16 billion, if I'm not mistaken. But it's also around there. So they are pre-trained and very easy for us to use. So what I'm trying to do here is trying to load this GPT-2 model through its tokenizer. And once I load it, I'm now able to download it. So this is me downloading that pre-trained model. And what that pre-trained model is, it comes with its vocabulary. The vocabulary are the words that are available within this particular model. You've been to ChatGPT and you ask it something and it tells you, as of my training or as of 2022, I do not know about that. So like for instance, you cannot ask ChatGPT about something that happened on Sunday. It is not available in its vocabulary. It's not yet been trained on that information. It can only give you information up to around 2022. That's when it was trained. So you get this vocabulary, and this vocabulary, like I've said, these models are not so much big. It means also the vocabulary is not that huge. There are some words or things that are missing. Then these are the merges between those different vocabularies. So the merges is, if I get this word and this word, what sentence does it make? And then the model itself. So the model, all Keras models end with .h, H5. If you ever meet a model that ends with .h5, that is a model. That's a Keras model. Then here, I'm trying to calculate the time, all right? I'm trying to calculate the time of when I give this large language model, the GPT-2, and I give it a prompt like say, my trip to Kabale for machine learning was. You all know about auto-completion, right? It's on all your keyboards if you're using this one. You start typing something and then there's suggestion. Okay? So this is how it happens. That for instance, I'll start something, I'll start a sentence, and then I say, okay, whatever words you're going to add there that probably rhyme with what I'm trying to say, make a maximum length of 200 words. And then I will have, so GPT-2 is going to do an output, and then I'll get that output and decode it to numbers, because NumPy deals with numbers, and then I'll calculate the time from when I gave it the prompts and told it to generate the next text to autocomplete it. Okay? So I'm not going to run these things directly here because running that very cell itself will take like 5 minutes or 10. Right? Because here's what is happening and why it is taking that time. You're saying my trip to Kabale for ML was, and you expect GPT-2 to autocomplete. GPT-2 is going through its 16 billion parameters and trying to match and see what makes sense. So in trying to do this whole magic, it takes time. You've seen this with ChatGPT. Sometimes it hesitates, tries to take time. It's trying to find the right words to autocomplete or give you the response. Okay? But this is what I got. I ran this thing early in the morning when Philip was texting me. I told him I'm coming at 9:30. I was trying to run this model because I knew I would come late and I may not be able to do it. But you can see you can see that in about 40, it's telling you 40 seconds, but it's not 40 seconds actually. It takes longer. But this is what it's supposed to be giving me. My trip to Kabale for email was very much in the same vein as the trip to the West Coast, blah, 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 blah. I did not write these things. All I gave this large language model was my trip to Kabale for email was, and then it started auto-completing. Okay? That's the magic that happens with large language models for natural language processing. I tried one, the stay in Kabale is, and then you saw the stay in Kabale is the first time in the city that a local government, blah, 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 and all that. So this is what it comes up with. But you can now notice that what it is adding onto what I've given it may just be random stuff. You know, it may not make sense to you. And I'll talk about the parts which you guys can now do on your own. And I'll be asking Philip and Simon for feedback on how you're doing it. It's called fine tuning. And I'll show you the code that does that. I already put it in here. So this is more understanding about how the GPT-2 model works from Keras. This is how the model works. This is the workflow or the flow chart of how it works. This is how the tokenization works. I'm going to rush through these things. So tokenization is each word that you see that is given. So for instance, when I said my trip to Kabale for ML was, you saw that I received the output as text. Okay? But the machine does not give you text. It understands numbers, right? So for instance, when I say today is a beautiful day, okay, this is what the machine actually gives me. These are the numbers. So this is the whole story. So this could actually mean that when you try to complete this, today is a beautiful day to learn about machine learning, blah, 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 blah. These are the numbers. How these numbers become text is this. This, encoding. Okay? So we use NumPy because NumPy works with numbers. It understands numbers. We use NumPy, get those numbers, decode them, and turn them into text. Which also brings me to something that you guys need to go and learn about. So I'm talking about GPT. Who knows what GPT is in full? I still have two, three pens here. Who knows what GPT is? Okay. I'll go back with my pens. No worries. Still need them. GPT. So GPT stands for Generative Pre-trained Transformers. Generative Pre-trained Transformers. The reason so the word transformers inside there stands for the transformer architecture. The transformer architecture, the reason why you have ChatGPT, you have Gemini, all those things, is because of one thing, transformers. The transformer architecture was developed by Google. So even when you use ChatGPT, they are using Google technology, Google architecture. And so in this architecture, you have an encoder and a decoder. When the training is happening, you have an encoder that gets your natural language, because computers do not know your languages. They do not know English. They do not know Luganda. They don't. But how do they understand? You put in your Luganda or your English or Swahili, which is text. That text is encoded into numbers or machine code. And then it is decoded into text again. So every time you go to ChatGPT and say, I want to know who is the current president of this country, picks that immediately, turns it into machine code, then gets the answer that is corresponding in numbers, then decodes those numbers back to you in text. And these things happen in split seconds that you never realize. Okay? So that's what happens, that decoding and encoding. So these are the numbers. And also, if you want to check if numbers are present, you can always get the true or the false. So for instance, in this whole story that I've gotten, this whole story, I can check for where are my texts? The one that I wrote, where are they being placed? So for instance, if I say today is a beautiful day, then it means these are the true values. These are the true words that I wrote, and the rest is being generated by the large language model. Then the backbone. So this here if you're a fan of research, and you know how to read research papers, go and read a research paper called Attention is All You Need. It was published in 2017. Attention is all you need. That paper is the basis of transformers. Without that paper, you may not have had ChatGPT. So attention is all you need. Okay? So this is the formula for that attention. As you can see again, it's mathematics. So you're welcome. So let's be mathematics. So this is some bit of how it works. So this is the thing. Attention is all you need in 2017. So you can fine tune this. So there's this CNN daily data set. It is almost it's a live data set that is always updated with we call them transcripts from CNN's daily news. So every time there is a news broadcast from CNN, every TV station or radio station transcribes the news they read for. Okay? If you go to any radio station and ask them, what did you guys anchor on this day in 2019? They will look through the papers and give you the transcript of what they read. Now, CNN makes its transcript daily. Like it's always updated daily. And so there's that access to it that you can use. And so this part here, the about 20 cells here, it is part of code that instead of giving me that gibberish that you were saying, where I'm saying my stay in Kabale is, and then it puts something that is a bit related, but when you read it all together, it doesn't make sense. It is gibberish. So how do you get such kind of a model to accurately give you something that makes sense? You fine tune it, right? You fine tune it to a problem. So for instance, the problem here is I want to give it a prompt. And when I say today is a beautiful day, I want a response. I want you to autocomplete something that is close to what guys say on TV, in news. You've been on TV and someone, like Samson or somebody else, no, today is a beautiful day. So what does an anchor say in that context? Versus to what you say. All right? So I'm trying to fine tune it in the place of news. What do the news guys do or say? If I wanted to say, today is a beautiful day, or for instance, there is this part where I saw, there is this part where I'm saying my stay in Kabale is, so it starts the first time in the city that a local government is considering allowing a private hospital and all that. Now, instead of giving me this generalized sort of data, it could be that something like the stay in Kabale is the first time I've witnessed the Kabale local government, right, trying to consider allowing other private universities, hospitals, besides this and this and this. So in the fine tuning, I'm trying to direct it to specific vocabulary, not the general vocabulary. Otherwise, if you leave it on the general vocabulary, it will give you all this gibberish. So ChatGPT it's already fine tuned. That's why when you give it your query, it gives you something that is close. Of course, there is a challenge, but it's a bit close. Okay. All right. So let's try to wrap this up. There's a lot of things that I've put together in this notebook. So this is introduction to now TensorFlow Lite. So if you built your model and it's able to autocomplete things, so the question is, it's built by Keras, right? How do I get it my Android app? I need to do TensorFlow Lite. So TensorFlow Lite helps us to optimize and convert our models. Optimization is you have to optimize for devices. There are devices that are made based on their chips, on the make of their chips. There are devices that can support float 16, float 32, integer 8, integer 16, integer 32. You've seen the architectures of your machines. We have 32-bit machines and 62-bit machines. When people are developing software that goes on these machines, they develop, if you develop something for 64-bit, it can go on 32. But if you develop something for 32, it cannot go on 64. So it's the same thing here, that we are trying to optimize our model to be able to run even on the lowest device. Whether you have your Alcatel or Motorola or Itel, should also be able to, when you download that app, the model inside that app should be able to run on your devices. So that's the optimization that happens. Okay? And once we've optimized this model for the lowest of devices, okay, and also this, when we optimize for the lowest devices, it means our model is not heavy. Okay? You may want to convert your model without optimizing it, and you download a model of 500 MBs. Then you have a mobile application which, when you release, is also 200 MBs. So that is a total of 700 MBs. And people will not download your app. Someone will be like, no, me, I can load my 200 and get just 200 MBs. I cannot download your app. So you have to optimize the model in a way that it is around 80 MBs, 100 MBs, depending on how big it is. And then when you couple it with a mobile application, you get something relatively small. So this is the whole architecture of the converting, the interpretation that happens. So you have TensorFlow, you get a TensorFlow Lite model, a TensorFlow model. You convert, use the TensorFlow Lite converter, and you get a TensorFlow Lite model. So this is on your workstation. This is on my computer. On my computer, because I have a CPU, or because I'm training my model, I can use TensorFlow, and I will have a TensorFlow model in my computer when I'm still in my notebook. But when I want to get that very model, put it on a mobile device, then I call in the TensorFlow Lite converter. It converts it to the TensorFlow Lite model, and then your mobile devices are fitted, or they come with a TensorFlow Lite interpreter, the one that is able to interpret this TensorFlow Lite model back into a TensorFlow model. All right. So some of these things may be confusing for now, but no worries. You will understand them once you go through these things. But so this is the optimization. I want to show you where I'm doing. So this is the optimization I'm talking about, but you'll understand some of these things later. This is where I'm releasing my model. So this is the model that I get at the end of the day after optimizing it and converting it to a TensorFlow Lite model. So the model has to come with .tf Lite. Okay, that's the extension that it's supposed to have. I'm sure it is already out of my it's already out of my runtime here, but the good thing is I had downloaded it. So this is Android Studio. Just a moment. Downloads. So this is the model. It's somewhere. Oh, I pushed it. It's here. So this is the model. Now, the beauty about mobile programming is one. I'm not a proficient mobile programmer, but the mobile platform supports machine learning or deep learning. Android Studio has the ability of, when you drag, this is a downloaded file that I downloaded, I dragged it in this folder called assets. Now, The folder where I dragged it in is because I'm using one, an updated Android Studio, but also it is on Mac OS. For Windows, if you go to your settings, there is where you can import a new file. I just don't have it here, but I know that in Windows, there's where you can import a new model somewhere around here. You can import a new or create a new TensorFlow Lite model, and you directly import that file. Here, I just drag it from my downloads, drag it into that folder, and once I've dragged it, it means should I choose to run build? So build is the process when you're releasing an APK of your mobile application. Should I choose to run build? This model plus my application are going to be bundled together. And then I'll have an application. And once you install my application, because the model is within the app, it means you can use it even when you're offline. Yes, it means I can go to this application. If it's doing prediction, I can predict without needing data because the model is within the app, which would be different if you served your model on the cloud. So if you didn't bundle this model, if I decided to get this model, go to Google Cloud and use Vertex AI or Google AI Studio to deploy it. It means I'm going to get what we call APIs that connect the model to my app, so that whenever someone clicks on a button, like let's say predict, it communicates with the model which is in the cloud. And for that, you need internet for you to communicate to that cloud. So these things help you to understand, like I'm building, but who am I building for? For instance, if you're going to build a model that can classify bean diseases or maize diseases, and this is for farmers in Kabale, the biggest challenge is already one, that not all of them have smartphones. But even the few that have smartphones cannot afford internet on a daily. So it means your whole application with this model is useless if it needs internet. But with this approach, where you deploy locally, right, your farmers are able to use your application along with the model without needing internet. Okay? So, away from that, so what I have here, this is a very simple app. Don't worry, I'm going to get to it. It's a very simple app built using Kotlin, right? So I'm using Kotlin, which is one of the best mobile programming languages that we have, to build it. And all it is doing is one. When I get to enter in a text here or something, and I say, hello, hello there, and I click on the button down here, which is called generate, it's going to do the auto completion. You saw the auto completion in my notebook. But like I had said, you cannot now go to a company and say, you guys, you see, I'm now a proficient machine learning engineer. Can I show you my notebook? No. What you've done in your notebook should transfer to a product, mobile or web or something. So that's why you have to deploy that model into something like a mobile application. Let me see if I'm able to zoom in on this application. I'm just going to first close this. Going to push this, and I'm going to zoom in. So this is just a simple application. It's just one interface. You know, when you load it, just get one interface. So you can, what you do is you can start typing in here to begin something like, this is want a story. So you start putting in your thoughts, and after that you click on generate, and then you get the story. Okay. So what do you want us to put in, and we see what it generates? Anything? Anything what you want me to type in so that it auto completes and we'll see what happens. Right. So my first day, at Kabale was. Right, so let's see what it gives us. So I'm going to say generate. So it's now going through the model that is within Android Studio, not in my notebook, because the model is already locally within my machine. So all this is through that TensorFlow Lite model. It's what it is communicating with. So which means whether I have my notebook or I give you this application, and then it starts its thing. So my first day at Kabale was the first time I saw the movie, and I was like, wow, it's a really cool movie, and I'm really excited, blah, 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 blah. If you feel like, for instance, now, this is gibberish, it doesn't connect. You click on new suggestion, tries to generate a new story. The moment you feel like, this is a story that I can now copy and put in my SE or something, you click on accept. So it is a very simple, very small demonstration to show you what natural language can do, how these things can be done, and you achieve something. Okay? So if that is something that I really want, I can now click on accept. And once I accept, I can copy this, put it somewhere. Isn't this close to what ChatGPT does? Good. So I have my own ChatGPT. I'll put it on Play Store and you start interacting with it. So in instance, this is what happens. I'm going to minimize this a little bit. Then try to get back this one. Because now I want to go a little bit in the code as I finalize. 2 minutes to 5. Yeah, one time. So you know the Android. You guys have done Android. Mobile programming. That's not everyone I know, but those that have done mobile programming, you know the Android manifest, you know the main activity, doing your screen and all that. So this is the autocomplete. So this is me trying to get and see if I can find the model. This is me trying to pick up the context. So in trying to generate or autocomplete, we have something called context. Context is, if I say my first stay at Kabale was, the model is trying to find the context in which you want your story to be like. Okay? So for instance, the other it said, my first stay at Kabale was like a movie. So it's already trying to pick up that maybe your story is rotating around something that is like a fantasy, something that was good. I mean, if it was your first stay in Kabale, ideally it should be a good stay, right? So the context, it has to pick up the context. Then the language checker. So the language checker is I'm trying to check the language in which you're typing. So if you type your Uganda there, hey, my friend, me and the model will fight with you because we've not supported Uganda. And then the dispatcher, this is now dispatching what we've got. And then there is some sort of other logic that is happening there. I cannot exhaust everything that is written here or that I wrote, but this is the whole file that enables me to do what? That enables me to do what you've seen here. This is where I declare a variable, TensorFlow Lite, and I connect it to the model that I downloaded. So the autocomplete.tf Lite, this is where I get it, right? And once I get it, I establish what we call an output buffer. So this is where the model is going to generate its text into. And then the word count, so the word count here can be reduced. So if I want a very huge story of about 2,000 words, 5,000 words, I can make it that. And then retry on body language 3. So on body language is something that we do when we are trying to evoke these products. Like for instance, ChatGPT. You cannot use foul language, with ChatGPT. It will actually even warn you and say, no, I don't need the vulgar ones, right? You can, yes, to warn you. Secondly, you cannot go and search things to do with harm. For instance, you cannot go to ChatGPT and say, okay, time for class. I need you to show me steps of how to develop a bomb. It will not give you that information. It's not that it is not trained on it, it's trained on that data. But once you train it on that data, we now specify and say that this data should never get out at any day. You can't just go to ChatGPT and say, okay, I want to read how to start a rebel army. No. We do these things to do what we call responsible AI. We want to provide AI that everyone can enjoy, that can be productive for everyone. Not you learning how to kill people and something, no. Right? So the body language and things like that is what we try to cover out. So also, you're going to get access to this. If you have Android Studio, you can run it. It's code that doesn't really have much errors. Try to work around with the errors. And just basically has 3 files that are important. So you have the model. You're going to have access to the notebook. So you can run the notebook until you download the model. So you cannot download the model